Hi folks, we're going to solve 6a from the test 3 preparation. So here we have 3 equations and 3 unknowns, and I'll start off as usual by labeling my 3 equations. Okay, so just recall our strategy for solving these systems here is that I work with 2 equations at a time, and I start with 2 equations and I eliminate a variable. Then I take another pair of equations and I have to eliminate that same variable. So remember that you have to eliminate the same variable the second time around. So I look here and I notice that on this column, I notice they all have coefficients of 4 or negative 4. So I think it makes sense to eliminate the y variable in both my pairs. So I'll start with equations 1 and 2. So equation 1, 2x plus 4y plus 3z equals negative 14. And then 2, I've got 3x minus 4y minus 2z equals 24. Now you'll notice here I rewrite the equations instead of just subtracting. I just do that to make sure it just seems easier to add and subtract them when they're one over the other, okay, separately. So I do take the time to rewrite the equations. So here I've got 4 and negative 4. Since the signs are opposite, we are going to add the 2 equations, and we're left with 2x plus 3x, so 5x. The y's reduced to 0, and then here 3z minus 2z, so plus z is equal to, that will be 10. Okay, so since now I've created this new equation which I'm going to use, I'll label it a different number, so I'll call that equation 4. So here, well, since I've cleared up number 1, let me use 2 and 3. So equation 2, we have 3x minus 4y minus 2z equals 24. And then equation 3, again, we don't have to do anything to either of these since we've got coefficients of 4 and negative 4 for the y. So minus 2z equals 14. And again, because the signs are opposite, I'm going to add the 2 equations. So here we're left with 8x. These cancel out. Negative 2 minus 2, so minus 4z equals 24, 34, 38. Okay. Now here I notice that 8, negative 4, and 38 all share a common factor of 2. So while I could work with this equation here, it'll just be easier if I divide both sides of the equation by 2. So I don't change the relationship if I'm doing the same operation to both sides of the equation. So I'll start by just dividing both sides by 2, so that becomes 4x minus 2z equals 19, and I'm going to label this as equation 5. Okay, so now I look at 4 and 5. So the next step, once I've eliminated the same variable twice, is I'm left with a system of 2 equations and 2 unknowns, here both in x and z. So easiest way to solve this is, I guess I'll multiply equation 4 by 2, so I end up with a 2z. So I'll do 2 times equation 4, so we end up with 10x, okay, plus 2z equals 10 times 2 is 20. And now I can eliminate the z variable here. So same sign, opposite sign, so I'm going to add the 2 equations. So here we end up with 14x. These cancel out, equals 19 plus 20 is 39. Okay. And now here, I probably meant this to come out nicely, but I guess didn't quite turn out that way. So here we've got x is equal to 39 over 14. Now I certainly could ask you to solve this equation and give the answers to 2 decimal places, but you know what, I'm going to try to find exact solutions. So I probably wouldn't give you a question like this on a test where you had to work with these kinds of fractions. Okay, certainly could give you easier fractions, 1/2, 2/3, but let's go ahead and finish this off. So now that I've found the x value, I can go back to this system of equations here. And in fact, if I go back to equation 4 up there, that would be the easiest one to determine z. So here, equation 4. So I'll solve for z. Z is equal to 10 minus, bring the 5x to the other side, so 5 times, and here we have 39 over 14. So I'm going to have to subtract these, so I'll put everything over 14. So 10 can be written as 140 over 14 minus, and let's just see what 5 times 39 is. Here, 5 times 39 is equal to 195. So 140 over 14 minus 195 over 14. So that gives me here 140 minus 195 is equal to, 195 is equal to negative 55 over 14. Okay, so now to solve for that third variable, okay, so let's just put a box on these. Okay, we'll go back up and choose one of the equations that also has a y. So I'll take equation 1 there. So we've got 2x plus 4y plus 3z. So here, if we take equation 1, 2x plus 4y plus 3z is equal to negative 14. Okay, and so here we have 4y is equal to negative 14 minus 2 times x. Bring that to the other side, so 2 times 39 over 14. And then bring the 3z to the other side, so minus 3 times negative 55 over 14. Okay, and again, I'll put everything over 14 here. So this is a good review of operating with fractions. So 14 times 14 is 196. So negative 196 over 14 minus 39 times 2. That would be 78 over 14. Notice I don't bother simplifying here since I want everything over 14 anyways. And then plus, well, 3 times 50 is 150 plus 15. So plus 165 over 14. So we have 4y is equal to, let's calculate that here. We've got negative 196 minus 78 plus 165 is equal to negative 109 over 14. Okay, and then here we have to divide by 4. Okay, so it means that 4 will just go into the denominator. So it'll be negative 109 divided by 14 times 4, which I believe is 56. But let's just check that. There we go. Yeah, negative 109 over 56. And there we go. So obviously this is a little more complex because of the fractions we had to deal with. But let's just recap what we did. We started with 2 equations and eliminated a variable, in this case here a y variable. Then we took another pair of equations and eliminated the same variable, and then solved the equations in 2 unknowns that were left over. Okay, that is it for 6a. So it turned out to be a little more exciting than we thought.